Hello class, I hope you're having a wonderful day. Today I would like to complete a practice problem from Chapter 2 that involves a position time graph. So I'm going to read the problem to you and I'm going to graph the data and we will calculate part B and C together. So let's take a look. It says you start to walk toward your house eastward at a constant speed of 5.8 kilometers per hour. At the same time, your sister leaves the house riding a bicycle westward at a constant speed of 27 kilometers per hour. The total distance from your starting point to the house is 3.5 kilometers. Now there's three parts to the problem. In part A, it says draw a position time graph that shows both your motion and your sister's motion. And so what I've done here, to save time, I've already drawn a position time graph. I've drawn both axes and I've labeled both axes. So whenever we say position time graph or a position versus time graph, what we're doing is describing the dependent variable first and the independent variable second. So position versus time. On position, we have units of meters, and for my x-axis, I have time with units of seconds, okay? So what we want to do is first use some dimensional analysis to convert you and your sister's velocity from units of kilometers per hour to units of meters per second. So right here we have the velocity of u, so I'm going to use a subscript of u. We're traveling at 5.8 kilometers per hour. And we're going to use some dimensional analysis to convert from kilometers per hour to units of meters per second. So we're going to treat our units as algebraic quantities. So in 1 kilometer, so I have kilometer in the numerator, we're going to put a kilometer in the denominator. 1 kilometer is equal to 1,000 meters. So units of kilometers, boom, they're gone. Okay, units of hours, in 1 hour. So I put hours in the numerator here to eliminate, to cancel out with the hours in the denominator here. In 1 hour, how many seconds do we have? We have 3,600 seconds. Nice. Boom. Hours are gone. This is going to leave us with units of meters per second. So what I would like to do is for everyone to grab their calculator here. So I have 5.8 times 1,000 divided by 3,600. This is going to give me 1.611 meters per second. Okay? And then the velocity of your sister. Now, remember that velocity is a vector, it's not a scalar. And for a vector, we are required to show both magnitude and direction. So it tells us in the problem that your sister is riding her bicycle westward. And so that's in a negative x direction, so that's going to be a negative velocity. So I have a negative 27 kilometers per hour. We're going to use the same process of dimensional analysis to convert from kilometers per hour to units of meters per second. So kilometers, in 1 kilometer, I have 1,000 meters. And in 1 hour, I have 3,600 seconds. Right here, we have units of kilometers that cancel and units of hours that cancel. This is going to leave us with units of meters per second. So I have a negative 27 times 1,000 divided by 3,600. This is going to give me a negative 7.5 meters per second. Now, what let's do is let's show the velocity vectors on a simple diagram that we have. So here you are walking to the east. So the velocity of u, and our vector arrow is showing the direction, positive x direction or east. This is 1.611 meters per second. Then we have the velocity vector of your sister pointing in a negative x direction. And the velocity of your sister is 7.5 meters per second, and that's negative or westward. And we do not need to write a negative for this value because you are showing that your sister's velocity is negative with the vector arrow, okay? So numerically, we have negative 7.5 meters per second, but graphically, we have 7.5 meters per second headed in a negative x direction. So what we're doing is saying the same thing here, okay? What I want to do is now calculate the time that it takes you to travel the 3,500 meters, okay? And what we're going to do is use an equation from chapter 2 that says the final displacement of the object is equal to our average velocity identified by v bar multiplied by the time interval plus d sub I. So our initial position with respect to the origin. Well, what we need to do now is take a look at the diagram here, and this is our origin. Okay, so I'll just write origin here and I'll place a point here. So you are starting at the origin. So d sub I in this situation will be 0. Since it's 0, we'll just go ahead and get rid of it, okay? We know that your final displacement is 3,500 meters. This is equal to your average velocity. Your average velocity is a positive 1.611 meters per second multiplied by the time required to travel the 3,500 meter distance. So to isolate delta t, what we're going to do is divide both sides by 1.611 meters per second. So what I have is delta t is equal to 3,500 meters divided by 1.611 meters per second. So let's grab our calculator here. 3,500 divided by 1.611 gives me 2,172.56. Now let's take a look at the units, okay? So in my numerator, I have units of meters. In my denominator, I have units of meters per second. Now, algebraically, we can write our numerator as meters over 1, and we're dividing this by meters per second. And what we need to do is think about that old algebra rule that tells us that whenever we divide fractions, it's like multiplying by the reciprocal of our denominator. So what I have is meters over 1 times the reciprocal of our denominator is going to be seconds over meters. And as you can see, units of meters will go ahead and cancel out, leaving us with units of seconds. Okay? So what this is really telling us, what we need to do is think about this. This time, okay, it's telling us for us to travel 3,500 meters moving at 1.611 meters per second, it will take us 2,172.56 seconds. And what we can do is actually graph this on our position time graph, okay? So remember that you are starting at the origin, okay? So our position is 0. At a time of 0 seconds, you are at a position of 0 meters, okay? And in 2,172.56 seconds, so we're going to locate this on the x-axis about right here, you travel 3,500 meters. So I'm going to place an ordered pair, and I'm going to go ahead and label this. So our ordered pair, we always list the x value first. This is 2,172.56 seconds. And our y value is 3,500 meters. That's our ordered pair, and I'm going to do my best to, okay, so, all right, so I just connected our two ordered pairs, and I'm going to label this as u. All right, next, we need to calculate how long it takes for your sister to travel the 3,500 meters. So, I'm going to free up some room here. All right, once again, we're going to use d sub f is equal to v bar delta t plus d sub I, okay? Now, before I plug any values in and start talking about your sister, what I want to do is take a look at our graphic that I've drawn up here. You started at the origin, and when you travel the 3,500 meters, you are 3,500 meters away from the origin, from where you started. And so I've represented this on the position time graph. You start at the origin and you wind up 3,500 meters, okay, away from where you started. But your sister is starting at a position of 3,500 meters away from the origin, and she will end up at a position of 0 meters. So she will end up at the origin, okay? So our final displacement. So she will be at a position of 0 meters because she'll be at the origin. So 0 meters is equal to her average velocity. Her average velocity is negative 7.5 meters per second, multiplied by the time interval, the time it takes for her to travel the 3,500 meters, plus her initial position with respect to the origin. Well, look at this. She's 3,500 meters away from the origin. So, plus 3,500 meters. So what I want to do right now is just graph the initial ordered pair for your sister. At a time of 0 seconds, what is her position? Well, you've identified that right here. It's 3,500 meters. So I'm going to place an ordered pair here. At a time of 0 seconds, your sister is at a position of 3,500 meters. Okay? Now remember that the slope of the line on a position time graph represents the object's velocity. So right here, we have a form of y equals mx plus b, where n is the slope of the line. And look at this. We have negative 7.5 meters per second. So this line is going to have a negative slope. Okay? Let's calculate delta t. So my first step in this process is to subtract 3,500 meters from both sides of the equal sign. This will give me negative 3,500 meters is equal to negative 7.5 meters per second times delta t. Now I'm going to divide both sides by negative 7.5 meters per second. So delta t is equal to negative 3,500 meters divided by negative 7.5 meters per second. So I have a negative in the numerator and the denominator. Those negatives will cancel out. So let's grab our calculator. I have 3,500 divided by 7.5. This is going to give me 467. And let's take a look at units. Once again, I have meters over 1 divided by meters per second. This will equal meters over 1 times seconds over meter. My units of meters cancel, leaving units of seconds. All right, so we need to understand what this is telling us here. So your sister can travel 3,500 meters in 467 seconds if she has a velocity of 7.5 meters per second west. So what let's do is identify her final ordered pair, 467, maybe somewhere right here. And we're going to connect these 2 points. And this is your sister. Okay? And she has a negative slope here. The line has a negative slope because she's heading in a negative x direction. Remember, the slope of the line on a position time graph represents the velocity of the object. Okay? So in part B, so we've taken care of part A. In part B, it says identify at what time you and your sister cross paths. So it wants us to be specific. Let's actually calculate the value. Let's just not look at the graph and provide an estimate, but we can go ahead and do that. We know that you and your sister cross paths right here. And we could say, I don't know, that's approximately, around 400 seconds, something like that. But we don't want to approximate. What we want to do is calculate that, and we're going to do that by setting the equations equal to each other and solving for x. And in this case, x is time. So what we can do here, let me free up some room, is we have an equation for you and we have an equation for your sister. And what we're going to do is we're going to put it in this y equals mx plus b, our slope-intercept form for a line. And for you, okay, y, this is our dependent variable, equals m. This is the slope of the line. The slope is 1.611 meters per second. X is t, right here, plus b. Well, what is b? That's our y-intercept. And take a look at the y-intercept here. Right there, it's 0. So this guy is 0 meters, okay? For your sister, okay, we have y equals mx plus b. So we have y is equal to, m represents the slope. The slope of the line is negative 7.5 meters per second. X is t, in this situation, time, plus b. What is the y-intercept of this sister? Look at this line. Here we have the y-intercept, 3,500 meters. Okay. All right, and so what we can do is, I'm just going to go ahead and get rid of this. Because it's 0, we really don't need it. I'm just going to set these. We have y equals 1.611 meters per second times t. I'm going to set it equal to this equation. So I have 1.611 meters per second times t. And so y equals this. Here's y. We can plug it in right there. This equals negative 7.5 meters per second times t plus 3,500 meters. Okay? All right. What I want to do is add 7.5 meters per second t to both sides of the equal sign. Okay? When I do that, it will eliminate it over here. And so this will give me, here, let me write this down just so it's clear. Plus 7.5 meters per second times t is equal to 3,500 meters. Okay? So I have 7.5 plus 1.611, and this is going to be 9.111 meters per second times t is equal to 3,500 meters. Now what I want to do is isolate t, the time where you and your sister's your paths cross. So I'm going to divide both sides by 9.11 meters per second. So t is equal to 3,500 meters divided by 9.111 meters per second. So 3,500 divided by 9.111 gives me 384.15 seconds. Now I'm going to use the subscript of cross here. So 384.15 seconds. Okay? So, part B is done. I'm going to identify the time for this ordered pair, and the time is the x value, so 384.15 seconds, comma. And so for my y value, part C, it says identify the position that you and your sister cross paths, okay? So what I can do is plug our value for time into either equation right here, and it will give us our y value, or our position that we cross. So this one looks to be a little bit easier. So I have 1.611 times 384.15, and this will give me a position of 618.86 meters. So my y value here is 618.86 meters. Okay? All right, I hope this problem has helped you with your practice problems in Chapter 2. As always, if you have any questions, just give me a call or send me a message over Canvas or an email, and I will be more than happy to help you. I hope you have a wonderful day.